Okay, my video got cut off, so I have to resume here. Okay, so we have a final position minus an initial position, final minus initial, divided by t final, t initial. And that is our average velocity. Now, an example of where this comes from is always a graph. So we have a position time graph here, where our x is measured in meters, and that's the vertical axis, and then our horizontal axis is time. Now, our delta x over delta t, all that is the slope of this graph. Okay, so this is a straight line, this is just a slope. So our final value here minus our initial value here. So what we'll have is x final minus x initial, which we know as delta x, and then our t final minus our t initial, which is delta t. So the slope of this graph is the velocity. And when you're taking 2 points of a graph, it is an average. Okay, so again, slope of a position time graph is the velocity. That is the definition. Okay, acceleration. Same idea, taking the slope of a graph, but we'll get to that in a second. It is the change in velocity divided by the time. So it is how much faster are you going every second. So an example would be, let's say 10 meters per second So every second that passes, we are going 10 meters per second faster. That is defined as our acceleration. Or this also can be written as meters per second squared. So all you're doing is just simplifying the units that are here. So that is acceleration. The formula is just like this. So our acceleration is just delta v over delta t, where v is velocity and t is our time. Remember, the delta, that triangle, just means the final velocity minus the initial divided by the final time minus the initial time. Or in layman's terms, like we were saying before, it's the rate at which velocity changes. So as time goes on, how does velocity change and how much? So again, this is where it comes from. It always comes from a graph. And again, this comes from a straight line graph. So if we have a positive constant slope, this is what our acceleration would look like. So the slope of that line, the slope of this line right here, that is our acceleration. Again, it is just the change in velocity over change in time. In mathematical terms, that is the rise over run, of course. So in this case, our rise is going to be velocity, our run is our time. Okay, one last thing is instantaneous velocity. This is something that is a newer concept to you, and it is exactly what it says here. It is instantaneous. So this is the velocity at exactly one moment in time. So that is implying that it could change, and you guys have seen that that is true. So if we had a graph that was curved, then, if we had a graph that was curved, then we can see that the slope here is changing, which obviously implies that the velocity is changing. All right, so that's our graph. If this was velocity and time, we know the slope of that graph is the acceleration. Okay, now if we had the position versus time graph of this same relationship here, then it would be curved like this. And we did an exercise to figure out how to calculate velocities at exact points. So if we want the time, the instantaneous velocity right there, we're going to take an average velocity for those 2 points, and it will equal exactly the tangent at that point. So instantaneous velocity, it is just the velocity at one moment, because we know that this line is curving, so that means the slope all the way up and down here is constantly changing. So that means we are only interested in finding velocity right at this point. That is what we're looking for. Okay, The variable is the same as velocity. We just use v, and then the units are meters per second. Now you can use any distance over time, but the most common method is meters divided by seconds. Okay, hopefully this helped clear up some questions you may have had on some vocabulary that we've been using in this class. If you feel like you still need... Excuse me, I got cut off there really quick. If you feel like you have questions, please bring them to class, and I hope that this cleared up some confusion on some of the terms that we've been using in the classroom. All right, have a good night, guys.